Hello and welcome back to Let's Play Satisfactory. We've got a lot to do this episode, so I'm just going to jump right in. We're working on turbo motors, and up first is rotors. We are using an alternate recipe for both rotors and stators. Let's get the assemblers up. We're going to put our rotors right here. This is going to be the last thing we make along this line. I believe we need only two rotors with the alternate recipe. So this will be a fast one. One. I mean, I honestly don't need to go on the other side, but let's do it anyway. There's enough room between. Let's go over just a little bit more. Okay. Right here, it looks good. I'll put it into the south. One space between. Line it up. One space. Okay, let's select our recipe. Alternate rotor. Now these require 120 wire per minute total between the two, and that would be, what, 36 steel per minute. So steel's not going to be a problem, but for our wire, we're going to have to condense these lanes. I believe if we condense any of the two lanes, we'll be fine, so we'll just condense the bottom two here. And all I'm going to do to condense it is I'm going to put a splitter right here. And then let's get a conveyor pole. Let's see, we'll put this right here. So this will go here. We'll bring this all the way back here. Are we on the vent? Yep. Perfect. Oh no! Out of iron plates. Okay, gonna pause the video quickly while I get some iron plates. Okay, we're back with supplies. So we're merging this. We've got a splitter here. And we're just going to put a merger right in front of where our conveyor pole will be. And if I can hit the right button, there we go. 1, 2, 3, 4, 5. It's on the vent. Okay. So, actually, we need to put this back further. Splitter here. Merger here. Out a little farther. Okay. What's going on here with this? Let's try this all the way back here. Splitter. Merger. Alright. So now this lane will be split into these two belts, and since this belt will always be full, 100% of the lane will be merged onto the lower lane. So the lower lane before had about 73 belts per minute, and the lane above had 103, so now we should be at like 176. We only need 120, so we're fine. Now right here, splitter. Yeah, I don't know what's going on there. That's weird. And also, we're also using Steel pipes. Slightly offset. There we go. Steel pipes on bottom, obviously. Copper wire. Okay. That's all we need for our rotors. Doesn't take very much. Okay, we'll wrap it around. 1, 2, 3, 4. It's on the edge. Yeah. We'll come back here. This should be far enough, right? Splitter. Splitter. So you're probably looking at this and thinking, how in the world will 2 assemblers making rotors be enough to supply this mega factory? And that's a valid question. But the answer is that we're using 2 alternate recipes, one for the rotors, one for the motors. So these rotors assemblers will be producing 9 per minute. That's 50% more than the standard recipe of 6 per minute. Okay, so these 2 assemblers are the same as 3 assemblers using the standard recipe. Not a big change, but a change. And then the more significant change is the motor recipe. Here's our industrial storage container, which we'll get to in a second. You know what? The turbo motor alternate recipe may have something to do with it as well. Okay, rotors are done. That was fast and easy, under 10 minutes. We need to pick up the pace. We're putting stators right here. A little bit over to the side. We need 6 assemblers producing stators. We're also using the alternate recipe for stators, which I'm not crazy about, but gotta do it. If you use the standard recipe for stators, then they also require wire and steel pipes, which is super convenient because then, you know, rotors and stators would be using the same ingredients. But you lose some efficiency because the alternate recipe is more efficient. It's just the way it is. We're going for efficiency here. So 3 assemblers merging to the south. Space. Okay, 3 more assemblers. One space. Let's take a look at our recipe. Alternate stators. 60 quick wire per minute, 18 steel pipes. Steel pipes won't be a problem. For the quick wire, it's 60 times 6, that's 360. And none of our belts can support that, so we'll have to merge our quick wire belts. I believe if we merge the top two, we'll be in good shape. The top two have about 240 units per minute still. So I think we're going to merge them in this lane. Let's switch to the... So now I'm just going to put up a lookout tower. I need some vantage here. Okay. So splitter all the way back here. Merger up here. Connect the dots. Now this third wire will have about 480 per minute, which is more than 360, so we're fine. We're going to route this right here, I think. Right next to... Actually, we could just go right on top of it. And I like that, because we're going to need a fair amount of space here, right? And we could even... yeah, let's do that. Let's just split... We've got a splitter right here for steel pipes. We can just use that exit. Perfect. I love it. So we're going to wrap this all the way around. We'll put another splitter right here. Directly on top, if we can manage it. Good enough. This is... I guess we don't need to do that. We can just hit it from right here. 1, 2, 3, 4, 5. This is probably good. Is it on the edge? Yep. Whew. Okay, I'm probably going to have to go up quite a bit. Let's get a splitter on the same line as the merger. Okay, that's as low as we can go. And then this will connect to this. And we've got our materials coming up here. Steel pipes and quick wire. Come up here. This looks far enough. 1, 2. Yeah. It's a little unorthodox, but you know, it's gonna work. It's gonna work well. It's gonna look pretty cool. 1, 2, 3, 4, we're fine. We're on the edge. 2, 3, edge. Now on the vent, the edge. Okay, let's make sure this is far enough back. Oh, definitely. That won't be a problem. There's the save. Ooh, it's a long hitch. It's like a full second hitch now. Originally it was like a millisecond. Okay. Splitters. Now, stators are needed for both the motors and the turbo motors, right? Let's take a quick peek at the turbo motor recipe. We're using an alternate recipe. Yeah, so alternate recipe is 8 motors per minute, sorry, 7.5 motors per minute, and 7.5 stators per minute. So not too many. Let's look at the original recipe here. .5 motors per minute, same amount of motors. But it's only producing 1.875 turbo motors per minute, as opposed to 2.812. So a pretty big jump in efficiency. Okay. Anyway, the point of that was we need 2 outputs here. We're going to use an industrial storage container, like always. But we're going to have it facing to the south. We're just going to line it up with our merger. It's not going to be centered in the foundation, but it will be aligned with the merger. It's facing the wrong way. Okay. I believe we need to select the recipe. Yeah. Alternate stator. Did I power my rotors? I don't think that I remember to do that. That's going to be crucial. Okay. Let's hook up the belts. Nearly out of belts again. Those are all done. Yep, definitely not powered. It's fine, we'll address that right now. Okay. Power pole Mark III, we'll put it... Will it reach this far? I feel like it will. Yeah, easily. From there to here. Alternate rotor, alternate rotor. Why is this yellow? Did we forget to hook something up? Sure did. Sure did. We were just crushing it. Okay, it's green. Always just, just take a second, make sure that all the lights are green. You haven't messed anything up. Another Mark III power pole. We're going to put it right here. Catch the power grid. And then just all 6 of these. And we'll switch from reds, yellows to green. Okay, we're good. 20 minutes in, we've got rotors and stators up. Now there's no stopping. We're going to put motors right here. And I believe that's another, what is it, 6? 4? Yeah, 4 manufacturers making motors. So we're going to, did we align this? Yeah, we did. Good. That would have been a mistake I would have hated. Let's see how much room we can give ourselves. I'm thinking right here. Yeah, this looks good. Production, manufacturer. One. Two. Yeah, that's nice. Still plenty of room on every side. These will output to the south. One space. Okay, 2 more. One space. To increase that back to 6. Okay. So we're doing alternate motors. 5 rotors per minute, 5 stators per minute, 2.5 crystal oscillators per minute. This is the alternate motor recipe. The standard motor recipe requires 2 motors. Let's look at it, but it's 2 motors and 2 stators to produce, I guess we can't, to produce 1 engine. So now we have got 2 rotors and 2 stators to produce 3 motors. I said engine, I meant motor. But we have to include 1 crystal oscillator per motor. Yeah, 1 crystal oscillator per motor. Is that right? 1 crystal oscillator per 3 motors. There we go. Which doesn't make a lot of sense, you know, how do you split a crystal oscillator between 3 motors, but it is what it is. Okay. So, our components here. Obviously, rotors and stators will come from the north. Let's go far back here. We've only got 3 lanes, so I think this should be far enough. 2, 3, 4. We can go all the way to the end. It's a little tight right here, but it's fine. I guess, honestly, we could move this closer. Let's do it. You know, I know we're going to take the time, but I'd rather the spacing was more ideal. So let's just move it a few, like right here. That's going to make a big difference. Manufacturer. Yeah, right here. Oh, come on. Yeah, I like that a lot better. No! Oh well. Sorry for shouting. That was not intentional. I just saw my manufacturer deconstruct happening in the moment. Just losing time at every turn here. Okay, let's crank this back up to 6. Oh, almost did it again. When you're mass deconstructing, not only does it deconstruct everything you've selected, but if your cursor is over an object, it'll deconstruct that too. Okay. We're going to go all the way back here. 1, 2, 3. Do a quick test. Yeah, that'll be fine. Okay. Did I come from the right direction? Yeah. Okay. Yeah. So we'll start back here. So we can start all the way back here. 1, 2, 3. here, and here. Is that going to be long enough? Oh, so close. Nearly out of belts. Okay, this turned out pretty well. I like that. Okay, now the hard part, we need to bring crystal oscillators over here. You know, I think honestly we can just... There's the hitch for the save. Yeah, out of belts. We'll bring crystal oscillators around and we'll start them at this end. I'm going to pause the video quickly while I get belts. Save as much time as we can. Alright, and we're back with belts. So this setup here, this giant setup, is the crystal oscillator machines. And they're outputting to a box on the south, but then they're also wrapping around. We wrap them around for our crystal computers. So you can see right here, fairly close, actually like right next to our motors, is a belt of crystal oscillators. So what we're going to do is we're going to, let's see where we want this to be. Probably right here. Is this far enough back? No. I'd say we'll say right here. Better safe than sorry. Okay. Now that's going to interfere with this. We'll have to raise it up a belt. Oh no, the sun's going down. Hard to see. Okay. Is it aligned? No. Close, but no. There we go. No need to test if this is far enough back. I'm confident it will be. Yeah, cool. Okay, so this belt is coming from directly south. And it's going to wrap around on the north side. That worked pretty perfectly. Okay, and it'll end right here. Now these two belts on top will wrap around on the south side. Okay, need to extend that a little bit. Just we don't have to move these poles. Oh. Good. Not the bottom, just the top two. Okay, and they'll end right there. Now let's get our splitter set up. Crap. We'll go ahead and load a high on this side. Okay, belts. Skipping the first one. Alright. This is alternate motor. Now we just need an output. We're going to output to the south. We're nearly out of case industrial beams, but we've got enough for this. And let's get some power. We have a free connection here. We do. Excellent. Let's put a Mark III right here. Slightly too long. Just slightly. Okay. So right here will work. Jetpack. And we're in the business of making motors. We have to... missing a belt here. There they go. Alright, all that's left here is turbo motors. It's 4 manufacturers making turbo motors. So we need to bring our stators and our motors forward. Okay, best way to do this. Yep, that's how we're going to do it. Let's see. We're going forward right here. So let's do this. I'd like to get it as close to this as possible because, or even just using this going forward, leave us a fair amount of space on the side here. Okay, so that's on the edge. 1, 2, 3, 4, 5, 6. Now we'll need to go up 3 and 4. Let's see if that's too far. Nope. No clipping. Perfect. It's a 4 stack. Perfect. Actually, man, that just getting bad. Let's put this on the 4th one. And then we're just gonna grab these stators right here with the splitter, which are on the 3rd stack up. Move that over. Couldn't be easier. Okay, let's quickly check our recipe for alternate turbo motors again. See if we're missing anything here. AI limiters, radio control units, okay. Both of those are over here. Now we only need 4 manufacturers here. So I think we can fit them. And I'm not happy with the way this line is set up. We'll probably change that later. It's fine for now. We only need 4 manufacturers for turbo motors. We're going to align them with these manufacturers, so it's this row of foundations. Give ourselves as much room as we can. I think this is fine. 1, 2. How much room? Plenty of room. Yeah, plenty of room. Okay. Let's see. It doesn't really matter which direction we output to. This is the final product. But we're gonna output to the south again. Leave that room to the north open. Okay, so 1 space. 1 space. One space. Okay. So 4 products for this. Need a fair amount of room. This should be good. We'll test it, of course. Good. Okay. So these top 2 will be motors and stators, because they're coming in from tall stacked poles already. Is that too far? 1, 2, 3, 4, 5, 6. Just so slightly too far. Okay. Oh, that looks wrong. Yep. One space off. All right. Now we need to grab AI limiters. And what's the fourth thing? Oh yeah, radio control units. Radio control units are right here, I believe. Yep. And we've got AI limiters right here. Very nice. Okay, so yeah, we'll do the same as before. Actually, do we want to just wrap it all around? I kind of feel like we do. No, let's do it the same as before. Okay, is this going to be able to... Oh, it looks like there's going to be clipping. No? No clipping. Oh, are the items going to clip? Oh no. Just barely made it. Excellent. Okay. Now let's grab our AI limiters. It's the best way. Is that gonna clip? No. Okay, easy. Now this might be a clipping issue. But it's not. This is coming together really nicely. Yeah, that works for me. Alright. So these belts will be traveling in different directions. I actually think this is far enough back. The other belts will wrap around on the south side, the upper belts. Okay, out of iron rods. Pausing the video, be right back. Okay, we're back with iron rods and other supplies. Wrapping these around. Man, I hate the way that looks. Let's make it closer. Yeah, much better. Okay, so this is directly in the middle. Okay. Now about our splitters. Let's verify that this is far enough away. Yep, excellent. Alright. This side's done. Let's power these up. Did we select the recipe for everything? We did not. So just to verify this again, the turbo motor recipe uses 4 motors to produce 1 turbo motor. That's 7.5 motors per minute to produce 1 turbo motor. The alternate recipe we're using, also 7.5 motors per minute, but 3 turbo motors, so they're going 3 times as far, the same number of motors. That's how we can make the two assemblers for rotors stretch so far. 50% more from the recipe itself, and then triple motor output from the alternate motor recipe, and triple again from the alternate turbo motor recipe. So alternate recipes are really making those rotors stretch. Alternate turbo motor recipe. Alternate turbo. Okay, now we need some power. I should really just put these on my, there we go, hotbar. Should have done that quite a while ago. we'll put this, it's in the inside right here. Okay. And all of the LEDs are green. We're in business. I need to run and get some encased industrial beams for the Mark II storage container. And then we're going to jump straight into the last product of batteries, and that's going to be pretty quick because batteries only require 2 manufacturers. I believe this is where we're making encased industrial beams. Yes. Grab 2 stacks. Is it possible that the storage container has already been filled? Yeah, it is. That's nuts. That this massive thing is already filled with heavy modular frames. You know, just like maybe 2 hours ago we set that up. Alright, industrial storage, 1 space over, centered in the foundation. Turbo motors. Now finally, I'm going to use this little space over here for batteries. Yeah, I think that's what we want to do. So 2 manufacturers. We'll put them right here. Yep, plenty of room on all sides. I think we'll output to the north. No, let's output to the south. Why not? Player's in the way. That player should move. Alright. Let's take a look at a recipe. I don't think there's an alternate for batteries. If there is, I haven't found it. Alkylate aluminum sheets, wire, sulfur, plastic. Okay? So all of those 4 things are on the bus. Let's get set up here first. 1, 2, 3, 4. The vent. Will that be too far? No, good. Let's test. I think we're fine. Yep. No, that's too high. Should test this too. Good. 1, 2, 3, 4, 5, 6. I think we're just going to do this one straight up against this wall. Okay. 1, 2, 3, 4, 5, 6. 6. Just counting off 6 foundations. That's the maximum length the belt's gonna go. What's the best way to do this here? Guess wrap it around. Yeah, that'll be fine. There's the save. So many stackable poles. Okay. Now, I've forgotten our 4 ingredients, and we need sulfur and wire. What else? Alkylate aluminum sheets. And plastic, right? So we should, how much wire do we need? Let's check. It's 45 per minute, times 2 is 90 per minute. So let's grab the third. The third belt of wire will have enough. Okay, that's 1, 2, 3. Now we need plastic and sulfur. Okay. Plastic's directly below cement. And we're basically going all the way to the top here. So this is cement, this is plastic. Sulfur and alkylate aluminum sheets are at the very top. That's great. Okay, sulfur is above plastic. Sulfur. And all the way up for alkylate aluminum sheets. And we'll turn. I'm gonna need a lookout tower here. Okay. All right. I'm gonna raise this. Let's see if we can get out with that. Pretty good. Okay, then we'll shift all of those down. Okay, the video's running really long. I'm just gonna pause it quickly while I run all these belts back to our manufacturers. See you in a movie minute. Alright, we're back. We've got all 4 lanes extended from the bus to our battery manufacturers. Let's put down an output industrial storage container. Now a few splitters. Last 3 belts. Now we just need power. Okay. Okay, and just like that, the production portion of this mega factory is complete. We have assembly lines set up that will produce batteries at a rate of more than 10 per minute. Also, heavy modular frames, more than 10 per minute, supercomputers, and turbo motors, all at a rate of more than 10 per minute. So that was the initial goal for this mega factory, and we've met it. I still want to do a few more aesthetic things. I'm going to do those right now as I pause the video. Mainly just raising the wall and putting a ceiling to have it just, give it a nice complete look. So one more movie minute. One thing before I start putting up walls, we should check our power. You can see that even under an almost full load, we're only around 9 gigawatts. So no risk of over extending our 21 gigawatt capacity. I say almost full because we know obviously a few of these boxes have already filled up, the heavy modular frames and probably the modular frames. At this scale, a industrial storage container fills up fairly quickly. Okay, now to put up some walls and a ceiling.